Let's look at Wi-Fi scanning with esp32s3 using esp IDF development platform. So the objective learn how to use esp IDF to scan for available Wi-Fi networks in the vicinity with the esp32s3 as the target platform. So we go through the esp32s3 introduction and then esp IDF setup. Then we look at the code for the Wi-Fi scan example and how to interpret the displayed results. So what is esp32s3? It's a microcontroller with the integrated Wi-Fi and Bluetooth, ideal for IoT applications with advanced AI capabilities. Key features: dual-core processor, enhanced AI capability with neural network processing, built-in Wi-Fi and Bluetooth. So here let's go to setting up esp IDF. The prerequisites are esp32s3 development board, the suitable USB cable, computer with the esp IDF installed. We'll go to the installation steps for esp IDF. Download and install esp IDF from the official guide. Set up the development environment like VS Code or another editor. Connecting to esp32s3. So wiring, connect to esp32s3 with the computer wires that provided USB cable. And let's go to the the configure the IDE part. So open the esp IDF project in your editor. Then ensure that we have the correct target selected, that esp32s3. Basic code setup is to initialize the esp IDF, include the necessary headers and initialize components, and set the Wi-Fi to station mode. Example code to initialize the Wi-Fi drive. The code we will examine next. So here the necessary header files are included. esp_wifi.h is the most important file here related to Wi-Fi. Then we define a tag for Wi-Fi scan for logging purpose. Next, look at the Wi-Fi scan function itself. So this Wi-Fi scan function here, it is not taking a parameter, but we are specifying a parameter word. So first we will declare one AP info with Wi-Fi AP record T as the type with 20 numbers. Now we will start esp Wi-Fi scan start and esp Wi-Fi scan get API records. This is API function that just calls, and this API function, the Wi-Fi scan get API records with get access point records, will scan in the background using esp32s3 Wi-Fi driver, and the number of access point found in the scan is reflected in the number variable, and the previously declared structure AP info will be populated with details of each access point found. Now we just log that the scan is done and found so many number of SPs, and we will print out each access point with SSID and signal strength. Now we go to the main function. We will do a flash in it, then we will get a default configuration for the Wi-Fi, and then we initialize the Wi-Fi and we set the Wi-Fi mode to station mode. Then we'll start the Wi-Fi, and then we'll call the Wi-Fi scan editor function that we declared and then we will create a task with the Wi-Fi scan that we defined in this screen. This is done as a separate task. So as I have explained the code, the first code will initialize the NBS partition, non-volatile storage, and then configure and start the Wi-Fi scan and retrieve and display the scan results. So we provide SSID, RSSI, and security settings like WPA, WEP. So how to interpret these results? The higher the RSSI indicates there is stronger signal that the access point is nearby, useful for selecting networks or monitoring signal strength. The common problems are like no access point found or scan delays or failure. So what we can do is you can modify the code to insert a delay and then do the scan again. And if you are unable to find existing Wi-Fi access point, then you have to check for signal interference and other radio side issues. Now we can use this for Wi-Fi network monitoring and automated connection to specific network. Next step, we can implement automatic reconnection logic and adding more features like handling network security. So further resources, the ESP documentation has a lot of resources. Along with that, we can go to the ESP32 forum as well as esp32 GitHub for more information. Hope that's helpful. Thank you for watching.